Okay, so now that we've done just individual means, like we just look at the whole raw data set, now let's talk about weighted means and the mean of group data. Now, you're actually more familiar with this than you even realize. So let's start with a definition, as we tend to always do here. The weighted mean is the mean of a data set whose entries have varying weights. Okay, and this formula is also on your formula sheet, so I'll show you where. You don't have to memorize it. I just want to show you where it is. It's in this, if I kind of zoom out, it's in this third area. So the third area of your formula sheet deals with weights and weighted values. How do you know it? We talk about frequencies. Oh wait, hang on, back up. Put it in reverse, Terry, put it in reverse. Weighted mean, sorry, I'm getting ahead of myself. It's right up here at the top. In this top box, this is weighted mean. So you don't have to memorize it. Yay! I am getting ahead of myself. We'll get to those other two here in a second. But for this one, let's see, what color did I do those top ones in? Green. I'll do this one in green too. So X bar is equal to the sum of the x's times the weights all over the sum of the weights. If I put that in a more simpler form, it's the sum of xw over the sum of the w's. Okay, so let's look at an example, shall we? We're going to start calculating grades. This is the application of weighted mean that you're familiar with, because y'all are all wondering, what's my grade? What's my grade? How do I know what my grade is? How can I calculate my grade? Here you go. This is how you do it. This is how we do it. Wait, I don't think that's how that song goes. Anyways, insert screen clip. Woo. There we go. Okay, your grades from last semester are in the table. The grading system assigns points as follows. A gets you 4 points, B gets you 3 points, C 2 points, D 1 point, F 0 points. Determine your grade point average. Your grade point average is a weighted mean. So, let's do that. Now, the points that we're going to have out here are given in the problem. So I'm going to just extend this table here, if you will. A C gets you how many points? It gets you 2 points. A C gets you 2 points. A D gets you 1 point. A gets you 4 points. C gets you 2 points. B gets you 3 points. Okay, these points, think of them as like our X's. That's what you're earning. You're earning points. The credit hours are your weights, because the more hours you take, that's how your points are going to be weighted. So I need another column to help me here to calculate the sum of the x times the w's. So I'm literally multiplying these. I'm going to do 2 times 3. 2 times 3, woo! Wait, I don't need the sum right there. I just need XW. So, 2 times 3, that's going to give me 6. 2 times 4. Why does it do that? I don't want it to do that. 2 times 4 gets me 8. And then I keep going. So 1 times 1 is 1. 3 times 4 is 12. 2 times 2 is 4. 3 times 3 is 9. Down here, I'm going to add them up. So the sum of the x times the w's gives me, I don't want that line there, buddy. There we go. Okay, so 14, 15, 27, 31, 40. Okay, there's my sum of my x times w. I need the sum of my w's. So come down here. Sum of the w's equals, I don't want that line there, buddy. Every time I do an equal sign, it puts that line. Getting annoying. Okay, 3, 6, 9, 10, 16. Okay. So now we need to do our formula. All that's left is our formula. So x bar, our GPA, if you will, is going to be the sum of the xw's divided by the sum of our w's. So that's going to be 40 divided by 16. It's going to get you a GPA of a 2.5. 2.5 GPA. Okay, so not the best GPA. If we're out there partying, maybe we need to do a little less partying and a little more studying. And for those of y'all that say, well, C's get degrees. Yeah, but just saying, if you're a doctor and you're like, to scare you, but I did make a C GPA in med school. I'll probably get up and walk right off the operating table. Like, nah, I'm finding another doctor. Thank you very much. Just say. Now, would you advertise that? Probably not. But anyways, a lot of scholarships, just for practical purposes, a lot of scholarships require a GPA of a 3.0 or higher. So, if you get lower than a 3.0, they may put you on probation and say, okay, buddy, if you want our scholarship this next semester, you better get your act together. That GPA needs to be up, above a 3.0. Or they may say, you know what? You don't qualify for our scholarship. We don't do probation. You know, you just lost the scholarship. So a 2.5 GPA, that's like a solid 75 average. For some, that's okay. But I wouldn't gamble a scholarship over it. Okay, so that's one example. Let's look at another example. So that's calculating your college GPA. This example is going to calculate your grade in a class. Okay, you are worried about your English grade. Wah, wah, wah. Okay, that was a bit mean. I'm sorry. Not really. You're worried about your English grade and want to calculate your average. Below are your grades and the weights for each category. So notice they already give you the X times the W. So what's our next step? We have the X, we have the W. We need to get X times W. Let's do it. times W. Okay, we're going to have 82 times 70. I cannot do that in my head. 82 times 70. 5740. $91 times 20. That should be, let's see, 182. $18.20. 95 times 10. It's going to be $9.50. Okay, now it's time to just go and get our mean. So we add up the XW's. So sum of your XW's, that's going to be 5740 plus 1820 plus 950. 8510. And then we add up the weights. Well, the weights add up to be 100 because it's 100%. So come up, we get 100. So then your average would be XW divided by sum of the W's. So 8510 divided by 100. It's going to get you a 85.1. So that's your grade in the class right now, is a 85.1. That is your grade in English. Okay. So that is weighted means. Now, let's talk about grouped means. So, we're going to come in here, do another definition. The mean of a frequency distribution, aka grouped mean, for, or I'm just going to say, can be calculated by, estimated. I'm sorry. Words are hard. Okay, now, a few different situations. Or I'll say a few. There's two situations. One is for a population, the other is for a sample. So if I'm dealing with a sample, remember for a sample we use X bar. X bar is equal to the sum of the X times the frequency divided by your sample size. So this is your frequency. This is your sample size. X is your midpoint. Okay, that's if we're dealing with a sample. If we're dealing with a population, then we're going to use mu equal to the sum of X times the frequency over the population size. Okay. Another thing to remember here, N is also nothing more than the sum of the frequencies. So these really tie together with our last example. Last two examples. That's why I'm doing them on the same video. So with that said, let's jump in and see an example. See this in action. Example number 8. Okay, let me go grab it. There it is, right there. Insert clip. Okay, the frequency distribution shows the out-of-pocket prescription expenses in dollars for 30 U.S. adults in a recent year. Use the frequency distribution to estimate the mean expense. Using the sample mean formula from the beginning of the notes with the original data set, the mean expense is $285.50. Compare this with the estimated mean. Okay. That's a lot. Basically, what this is saying is this piece right here is the actual X bar. How can I tell this is group data? This frequency right here tells me this is grouped. Grouped data. The fact that, really, quit. This computer is about to go out the window. That tells me it's group data. So I need a column of X times F. I'm also going to write down our formula. That way I know where I'm headed. X bar equals the sum of the X times the F over my sample size N, which, to keep it synonymous with what we did above, is the sum of the frequencies. Well, I need to get those. So if I add these up, some of my F's would be, I want to say 30. Oh, it tells us 30. Yeah, so that should be, give me 30. Okay, so this number is going to be 30. Okay, now for X times F, just like we've done before, we multiply these. So 172.5 times 3 equals, and then I'll put that number here. 172.5 times 3 is 517.5. 517.5. 208.5 times 2. 208.5 times 2. 417. Now, 244.5 times 5. 244.5 times 5. 1222.5. 1222.5. And I just keep going. So this times 2 equals that. That times 5 equals that. And I'll keep going in that nature. I'm going to use my little cheat sheet to expedite things. This is going to be 1683. 2215.5. 1410. And 1165.5. Now, once I get all of these, just like before, I need to add them up. So the sum of the XFs. If I were to add all of those up, I would get 8631. I'll let y'all check me on that. If you find a mistake, email me, and then I can edit the video. Okay, so I plug those into our formula. And with that, when I do 8631 divided by 30, get 287.7. So $287.70. Not 75. That is our average, so our estimated average. So it says compare the actual average with the estimated average. So our estimated was $287.70. The actual was $285.50. So it's not substantially different. Of course, the actual is a more accurate result, so our estimate is only off by $2.20. But with that said, the actual value is the more accurate result. But I mean, if you were like needing just a back of napkin or a back of a paper approach where you just do a little bit of scratch work, boom, there's your answer, without seeing the raw data, we get a pretty good value doing that. So we don't have the raw data here. Yes, I could flip back in my notes to 2.1, but just knowing this frequency distribution, I got darn close. I was only off by $2.20. So, yeah. Okay, so that's grouped mean and weighted mean. In the last video of 2.3, we're going to look at the shapes of distributions. Stay tuned.